Good morning, students. Yesterday we discussed about equations, right? Just a minute. Yes. We are discussing rational number, right? And yesterday we discussed about in previous classes we discussed about what is rational number, and in yesterday class I explained you that how can you represent rational numbers on number line, right? Also, you have learned to find out the additive inverse of rational number, multiplicative inverse of rational number, and now you are able to write the reciprocal of rational number, and also you can write a rational number in its standard form, and also you have learned to represent the rational number on number line. So now I request you to solve the exercise 1.1, the exercise 1.1 and exercise 1.2 on your classwork copy, right? The exercise 1.1 and exercise 1.2 in your classwork copy, because I have explained you all the related questions which are given in exercise 1.1 and exercise 1.2. In exercise 1.2, in question number 1, you have to represent few rational numbers on number line, and same thing is given in question number 2 also, right? Then in exercise 1.2, now we are going to discuss the exercise 1.2. In exercise 1.2, in first question and in question number 2, you have to represent few rational numbers on number line, right? And in question number 3, write 5 rational numbers which are smaller than 2. We have to write 5 rational number which are smaller than 2. Now, question number 3, we have to write 5 rational number which are smaller than 2. We have to write 5 rational number which are 5 rational numbers which are smaller than 2. So what will be the answer? Anybody? We have to write 5 rational numbers which are smaller than 2. Yes, you have to solve the questions of exercise in your classwork copy. Okay, now tell me the answer. The 5 rational numbers which are smaller than 2, what may be? we know that on the left of 2, if we represent this 2 on number line, then all the numbers which are lies left of 2 on the number line are smaller than 2, right? So on the left of number line, which numbers are here? Here is 1, 0, -1, -2, and so on, right? So all these numbers are less than 2, and we know that all the integers are rational number. Since 1, 0, -1, -2, -3, -4, and etc. all are integers, and every integer is a rational number. So we have to write 5 rational number which are smaller than 2. So we can say that the 5 rational number which are smaller than 2 are 0, 1, -1, -2, -3. That is right. It may be possible that your answers are different. Also, you can solve it like this. Look, can I write 2 as 20 upon 10? Can I write it as 20 upon 10? 2 is equivalent to 20 upon 10. Now, every number which is smaller than 20 upon 10 is also smaller than 2. It means if I write 19 upon 10, then this one is smaller than 2. Similarly, 18 upon 19 upon 10, right? 19 upon 10, 18 upon 10, 17 upon 10. All these numbers are less than 2. So these are the 5 rational number which are smaller than 2. So you can write this one also, and you can write this one also. So it may be possible that each student have different answer, right? So now you can write the 5 rational numbers which are smaller than 2 very easily, right? Now the next question, question number 4. So 2 can be represented as 14 by 7. Yes, obviously 2 can be represented as 14 upon 7. Okay. Now let's see next question. The question number 4. In question number 4, the question is find the rational number between -2 by 5 and 1 upon 2. -2 by 5 and 1 upon 2. We have to find rational number. How many rational numbers? It is not given, right? So we have to find the rational numbers which are lie between -2 upon 5 and 1 upon 2. We have to write some rational numbers which are lies between -2 by 5 and 1 upon 2. Right? So, in previous class, I have explained you that how can you find out the rational numbers between two given rational number. First of all, we will make the denominator equal, right? The denominator of the first rational number -2 by 5 is 5, and the denominator of second rational number, that is 1 by 2, is 2. So first of all, we will make the denominators equal. For this, we have to take the LCM of 5 and 2, and LCM of 5 and 2 is what? 10. Now, this -2 upon 5 can be written as what? -2 upon 5 can be written as -4 upon 10, is it? Look how. You can also do this like that, -2 by 5 and 1 upon 2. You have to take LCM, you will take the LCM as 10. Now 10 divided by 5 gives you 2, and 2 multiplied by -2 gives you -4. Then 10 divided by 2 gives you 5, and 5 multiplied by 1 gives you 5. That is -4 upon 10 and 5 upon 10. So all the rational numbers which are lies between -4 upon 10 and 5 upon 10 gives you the rational numbers between -2 upon 5 and 1 upon 2. Now look here. Here are the difference between -4 and 5 is, what is? Look here. Which numbers are lies between -4 and 5? Suppose this one is your number line, here is -4 and this is 5. So there are so many numbers, right, which are lies between -4 and 5, as minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, right? So you can write any numbers which are lies between minus 4 and 5 upon 10, and the number will be the rational number lies between these numbers. So we can write it as rational numbers lies between minus 2 upon 5 and 1 upon 2 are, which are from here, minus 3 upon 10, minus 2 upon 10, minus 1 upon 10, 0 upon 10, etc. Right? Because there are infinite numbers lies between any two given numbers. So you can write infinite rational number between minus 4 by 10 and 5 by 10. So I hope you are able to find out the rational number between any two given rational numbers, right? Okay, now the next question, that is question number 5. In question number 5, you have to do the same thing. Question number 5 is find 5 rational numbers between 2 upon 3 and 4 upon 5. There are 3 parts of question number 5, and in all the 3 parts you have to find 5 rational number between given 2 rational numbers. So I am not going to solve this question because I hope you are able to solve these questions by yourself. So try to solve this question at home by yourself. Now the next question, question number 6. In question number 6, you have to write 5 rational numbers greater than minus 2, and this question is very similar to the question number 3. In question number 3, you have to write 5 rational number which are smaller than 2, and in question number 6, you have to write 5 rational numbers you have to write 5 rational numbers which are greater than minus 2. You have to write 5 rational numbers which are greater than minus 2. Try to give the answers. Ritvik is saying as a minus 1 by 1, 0 by 1, 1 by, and what is this? 1 by 1, 2 by 1, 3 by 1, 3 by 1. Okay. Yes, right, Ritvik. Okay, good job. It means now you are able to solve such type of question, right? So many students are giving the correct answer. So 5 rational numbers which are greater than minus 2. So just simply draw a number line. Here is minus 2, and all the numbers which are lies on the right side of minus 2. All the numbers which lies on the right side of minus 2 on the number line will be greater than minus 2. It means minus 1, 0, 1, 2, 3, and so on, right? All these numbers are greater than minus 2. So you can easily write the numbers greater than or less than minus 2 or 2, right? Okay. Okay, good. So next question is the question number 7. In question number 7, you have to find 10 rational numbers between 3 by 5 and 3 by 4. You have to find 10 rational numbers which are lies between 3 by 5 and 3 upon 4. have to write 10 rational numbers 10 rational numbers between 3 by 5 and 3 by 4, between 3 upon 5 and 3 upon 4, right? You have to find out the 10 rational numbers which are lies between 3 upon 5 and 3 upon 4. Now, as I have explained you in previous question, that to find a rational number between any two given rational number, first of all makes the denominator equal. Here is in first rational number you have the denominator as 5, and in second rational number denominator is 4. So first of all make the denominators equal, and for this you can take the LCM of 5 and 4. Now tell me, what will be the LCM of 5 and 4? What will be the LCM of 5 and 4? $20. Okay. Krishna, Ritvik. Yeah, great. Good. Okay. Sailesh, all are saying 20. Good job. So the LCM of 5 and 4 is 20. Now, I want to make the denominators equal. It means I have to multiply the numerator and denominator by what? Because I want to make the denominator equal. So that I can multiply the numerator and denominator by which number? By 4, and this denominator by 4. Now I know that you can make the denominators equal, right? After taking LCM as this 20, right? Dividing 20 by 5 you will have 4, and into 3 12, and similarly here it will be 15. So 12 upon 20 is equivalent to what? 3 upon 5, and 15 upon 20 is equivalent to 3 by 4. Now, between 12 and 15, you have 3 numbers. Since between 12 and 15, there are infinite numbers. But we can easily observe here that 13 and 14 are the numbers between 12 and 15, right? For our convenience. Now, we have to find out the 10 rational numbers between 12 upon 20 and 15 upon 20. For this, to make this question very simple, we will just multiply the numerator and denominator both with any number, so that we will have here and here, we will have the two numbers between whom there are 10 different of rational numbers. For that you can multiply both the numbers, that is numerator and denominator, with any number, right? And you have to just multiply both the rational number with any number. Let's say I am going to multiply both the numbers by 10. So what will happen? 12 multiplied by 10 gives us 120, and 20 multiplied by 10 gives me 200. And similarly this number will become, after multiplying by 10, this one will become 150, and this is 200. Now I can easily find out 10 numbers between 120 and 150. So rational numbers are 10 numbers. We have to find out 10 numbers. So 10 numbers are which one? 121 upon 200, 122 upon 200, similarly 123, 124, 125, and up to 130 upon 200, right? So 121, 122, 123 up to 130. So these are the 10 rational numbers which will lies between 3 by 5 and 3 by 4. I hope you all understand this question. Anybody have confusion? Do you have any confusion? Yes, you can multiply by 8 also. You can multiply it with any number. I am multiplying by 10 so that we will have some multiple of 10s, so that we will find out the rational numbers easily. Now you are free to multiply the numerator and denominator with any number. You can multiply both with 100. You can multiply with 1000, 1 lakh, any number which you want, right? Okay, so all are saying that everything is clear. Okay. Okay, so everyone is saying there is no any problem, right? So you have learned the 3 marks question, right? In your examination, This type of question is given up to 3 marks. You have to find out different types of rational number between any two given numbers, any two given rational number, right? So you have completed this question, and also with this question you have completed the exercise 1.2. So this is the last question for exercise 1.2, and I hope this one is last exercise of your book, of this chapter also, right? So hence chapter 1 is complete. If anybody have any problem in any exercise, like in 1.1, either in 1.1 or in 1.2, so you can ask me. Do you have any problem in exercise 1.1 or in exercise 1.2? You can freely ask me. Somebody is asking, can you explain exercise 1.1 question number 1? Okay, Divakar, yes, obviously I can explain question number 1, and 1.1 question number example 5. Sorry, Ritvik, right now I cannot explain the example, right? Because I don't have the NCERT book right now. So I'll explain the example number 5 tomorrow, right? Because right now I don't have the question, the book, so that I don't have the example number 5. If you can write the question, Ritvik, if you can write the question given in example number 5, then definitely I will help you. Okay, so right now I'm going to, so many of you are asking about exercise 1.1 question number 1, right? Yes, LS, you can write the exercise. You have to write the exercise 1.1 in homework copy, right? In classwork copy, everyone, I request you, everyone, to complete your classwork copy. In classwork copy, exercise 1.1 and exercise 1.2, you have to solve. Explain the question number 3 in exercise 1.1. Okay, Amit, I'm going to explain the question number 3 also. Okay, so here we have 2 doubts. In exercise 1.1, there are so many students who are asking about the question number 1 of exercise 1.1, exercise 1.1, and question number 1 and 7, right? Okay, let's see. Just a minute. Okay, in exercise 1.1, the first question is using appropriate properties, find out. So look, as we have learned with the properties, in question number 1 there are 2 types of question, right? The first one is, I'm going to write the first question. The first question is minus 2 by 3 minus 2 upon 3 multiplied by 3 upon 5 plus 5 upon 2 minus 3 upon 5 multiply 1 upon 6, right? Okay, look, first of all, we have to solve this question using appropriate properties. With the help of properties, we have to solve this question. Look, first of all, look here, how many terms are given here? This one is first term, second term, and third term. So there are total 3 terms. Now just think about these 2 terms, this term and this term. Can you see anything special in these 2 terms? In these 2 terms? If you observe carefully, then you will get that 3 upon 5 is common in both the terms, right? Here is also 3 upon 5 and 3 upon 5 is also present here. It means you can take 3 upon 5 as common from these 2 terms. And for that, you have to write these 2 terms after 1 by 1, right? Look here. I can write it as minus 2 upon 3 multiplied by 3 upon 5 minus this one 3 upon 5 multiply 1 upon 6 and plus 5 upon 2. Any confusion here? Can I write this equation as this one? Anybody have any confusion? Now I can take common as 3 upon 5. So taking 3 upon 5 as common, look, if I'll take 3 upon 5 as common, then here is, we have minus 2 upon 3 and here is minus 1 upon 6 and plus 5 upon 2. If I'll take 3 upon 5 as common, then I'll have which numbers? Minus 2 upon 3 and minus 1 upon 6, right? And which property I am going to use here? Here I have used the commutative by commutativity, right? Using commutativity, I can change these two terms. I can change the place of these two terms, right? Right? With the help of commutative law. Now, what we can do? Just simply solve this thing. Solve this bracket. What will happen? 3 upon 5. If you will take the LCM at 6, then this one will become minus 4 and this is minus 1 plus 5 upon 2. So simply this one will become 3 upon 5 multiply minus 5 by 6 plus 5 upon 2, right? 3 upon 5 multiplied by minus 5 upon 6 plus 5 upon 2. Now what is I am going to use here is distributive property. Here is what? Distributive property. Now simplify this term, right? Simplify this one. What will happen? This 5 will get cancelled out by minus 1 and 3 2s are 6. So finally we have minus 1 upon 2 and plus 5 upon 2. So simply you can find out the difference between these two numbers and we will have 4 upon 2 and after simplifying this fraction we will get 2. So the answer is 2. So with the help of property you have to solve the question number 1. I hope you understand this question, right? Okay, now the question number 7. In question number 7 we have to ask, tell what property allow you to compute 1 upon 3 into 6 into 4 by 3 as 1 upon 3 into 6. Okay, look here. We have given, first of all, 1 upon 3 multiply 6 into 4 upon 3 as 1 upon 3 multiply 6 multiply 4 upon 3. The question is, which property, with the help of which property you can write this thing as this? Which property is being used here? Tell me which property allow you to write this term as A multiplied by B multiply C. Can I write this as A multiply B multiply C? Are both equal or not? We all know that both are equal to each other. So with the help of which property I can write this thing as this one? Anybody can tell me which property is being used here? Which property is being used? Divakar, associative. Good Divakar. So here is the associative property, right? Associative over multiplication. We are using here associative property. So the question is, with the help of which property? The question is, which property allow you to write this thing as this? So we can write the answer as, with the help of associative property, we can write this one as this. Right? Yes. Now, so this is the doubt session. I think you have clear concept of question number 1 and question number 7 of exercise 1.1. So if anybody have any more question, then you can ask. If you have any question, any doubt related to exercise 1.1 and exercise 1.2, then you can ask me. No. Okay. Good job. Okay, so all are saying that you don't have any problem. Good job. Then make sure you are you have made the copy. You have made the classwork copy, and you are doing the exercise per day in your classwork copy, and in your homework copy you are doing the practices, right? Because the practice in mathematics is very compulsory. You have to solve the questions of NCRT in your classwork copy, right? And in homework copy, you will have you can do the practice of the question which I am explaining here, right? Now look, today I'm explaining here the questions from your NCRT book, but before today class, in previous class, I have explained you few different questions from different books. So that question you should write in homework copy, and all the questions which are given in your NCRT book, you have to solve in your classwork copy, right? Okay. So this is for today. From tomorrow, from the next class, we will discuss the next chapter, that is chapter number 2, which is very interesting chapter, right? The chapter number 2, in which we will learn some algebra and about linear equation in one variable, right? So we will meet in next class to discuss the chapter 2. Thank you for joining us today.